In mechanical systems, a force acts on a spring to either stretch it or compress it. In this video, a load is gradually applied to a valve spring of stiffness S in kilonewtons per meter so that it varies from 0 to a maximum P and produces a maximum extension X. Derive the expression for the strain energy of the valve spring. This is a scenario whose kind of operation or application is found in the opening and closure of valves in an internal combustion engine. To answer this problem, we have to define what strain energy is, and this is the potential energy that is always gained by a material such as a wire or a spring when stretched by a tensile force. For a spring, if it is also compressed by a compression, a compressive force, and it undergoes a compression X, then at that position it is going to be having what we call potential energy, that is called strain energy. Let us consider a force P acting on a spring of constant K, compressing it by a compression X. This is the spring that is going to be acted upon by force P that is going to compress it by compression X. If we consider a point, for example 1 and 2, where that compression X is, then in the middle, let us consider a point that is going to be compressed by a smaller compression dx. If I plot a graph of P, which is the force against the extension or compression X, then we will see that this P is going to vary directly with X. And according to Hooke's law, we find that P is equal to Kx, because we know this force applied on an elastic material is always directly proportional to the extension of that material, provided that elastic limit is not exceeded. So if elastic limit is not exceeded, then P is going to equal to Kx, which will give you a straight line graph. It will give you a graph which is a straight line passing through the origin when P is plotted against X. Now if we consider small work done, the strain energy is the work done. So if we consider small work done, the S, that is equal to P times the small compression dx, then we will have that work done as ds equal to p dx. So if we need the total work done, that is the total strain energy, it is going to equal to the integral of p dx from 0 to x. So if I put in px in terms of k and x, then it will be the integral from 0 to x of kx dx. If I integrate kx with respect to x, then I will have kx squared out of 2, and I put in my limits from 0 to x, I will have a half kx squared, and since kx is p according to Hooke's law, then it means this s is going to equal to a half px, and therefore the expression to determine the strain energy that is stored in a valve spring when you compress by maximum compression X by a force, maximum force P, then it will equal to that total work done in compressing the valve is equal to S equivalent to a half times the maximum load that has been applied times the extension it has undergone through. Thank you so much for watching.